Okay, let's look at the homework 4.9, number 10. Right, so you have a car that is traveling at 102 kilometers per hour, right? Then we want to we would like to stop within 65 meters. So we want to come to a stop within 65 meters. Right, so that's 65 meters. Right. Then, assuming that we're applying a constant deceleration by hitting the brake, so let's see. So second derivative of the position function, which is the acceleration. So since we're slowing down, so it's going to be negative. So I put a negative sign. And then we don't know the constant deceleration, so I'll call that A. Right? So we can find the velocity function by taking the antiderivative of the second derivative. So v of t is simply antiderivative of negative a with respect to t, which is negative at plus the initial velocity, which actually already know it's 102 kilometers, right? But since we want the answer in meters per square second, we have to convert the units. So we have 102 kilometers per hour. We need to convert it to meter. So we have 1,000 meter is equivalent to 1 kilometer. So we can multiply that. That way we can get rid of kilometers, right? Then we need a per second instead of an hour. So we know that the 1 hour is equivalent to 60 minutes. Right? Let's go to minutes first. Right? And also, so that way you can cancel hours. Right? But we want seconds, so we know that the 1 minute is equivalent to 60 seconds. So you can cancel those, right? So you can see that on top you have 102,000 meters per. Right, you have 60 times 60, so 3,600 seconds, right? Then you can knock off 2 zeros and 2 zeros, and then you can just keep on simplifying it. Let's see, even number. You have 510, and 36 even number is 18. All right, divide by 2 again, 255, and divide by 2, you get 9. And I think we can divide by 3. So if you divide by 3, you get 85. And divide by 3, you get 3. Right? So 102 kilometers per hour is equivalent to 85 over 3 meters per second. Right? So this is the initial velocity v0. So velocity function can be written as negative at plus 85 over 3. Right? Then we can go back to a position function s of t. Right? So that's another antiderivative. So we take the antiderivative of negative at plus 85 over 3 dt. So it's equal to antiderivative, so negative a is just a constant. Derivative of t, antiderivative of t is t squared over 2. So we put that. Right? Antiderivative 85 over 3 is 85 over 3t. Right? Then initial plus some constant, but that's initial position. But you can think of initial position s of 0 as 0. Right? Then when it stopped, so that's going to be 65. Right? So we want to know when it comes to a stop. So when a stop means the velocity becomes 0. So we can set that equal to 0 to find that the time it came to stop would be 85 over 3a. Right? So we can plug this into a position function. So we compute s of 85 over 3a, and this is equal to, right, negative a over 2, then square that, so it's going to be 85 squared over 3 squared would be 9a squared, then a cancel out, and plus you have 85 over 3 times t is 85 over 3a, so it's going to be 85 squared and 3 squared and a. Alright, so basically you have 85 squared over 9a minus 85 squared over 18a. So it's going to be 85 squared over 18a. Alright, so this distance, so the time t here is 85 over 3a. So the distance is supposed to be, position has to be 65. So we can set this equal to 65. Right? Then we can just solve for a. So a is going to be equal to, right, 85 squared, I'm too lazy to compute that, and over 18, right, and then divide by 65, right? Right, so I'm going to cheat a little bit. I'm going to bring out a simple calculator. All right, so you have a calculator here. Right, I'm going to compute this. So 85 and square that, right, divided by 18 first, and then divided again by 65, right? So it came out to be about 6.18. So this is going to be about 6.18 meters per second, right? Which is the answer right here. All right, that's it. I hope that this was clear.